In exercise 19 of section 8.3, the dollar price for a barrel of oil sold at a certain oil refinery tends to follow the demand equation P equal minus 1/5 X plus 124, where X is the number of barrels of oil on hand in millions. How much should be charged for a barrel of oil if there are 8 million barrels on hand? So to find the price for that should be charged for a barrel if there are 8 million barrels on hand, we replace X with 8 and we get minus the price P should equal minus 1/5 times 8 plus 124, which equals minus 1.6 plus 124, which equals $122.4. All right, we want to round that to the nearest cent, so we want to charge $122.40 for each barrel of oil. Now we're asked to find the quantity that will maximize revenue. And we have to understand that revenue is the money that comes into the company. So let's call that function R of X. If I'm selling X million barrels of oil at P dollars per barrel, then X times P will be the money that comes into the company, which is the revenue. But P is minus 1/5 X plus 124. So the revenue function is minus 1/5 X squared plus 124X. So when I go to maximize revenue and I want to find the quantity of barrels of oil that will actually maximize the revenue, then I need to find the X value that equals minus B over 2A. That equals negative B is 124, so negative 124 over 2 times negative 1/5. And if you want to write negative 1/5 as a decimal, that would be negative 0.2. So negative 124 is divided by negative 0.4. And that gives me so that equals to 310. So the quantity that will maximize revenue is 310 units. And then we want to know what is the maximum revenue. And that involves us taking the 310 and replacing that for X in the revenue function. So I want to find R of 310. So minus 1/5 times the square of 310 plus 124 times 310. And I use my calculator to calculate that value. So this equals 19,220. And these are dollars, so this is my maximum revenue. So the maximum revenue is $19,220. And we want to know what price should be charged for the maximum revenue. So we go back to the demand function, which tells us the price, and in place of x, we put that x value that maximized revenue. And remember that the quantity that maximized revenue was 310 units. So in place of x in the price function, also called the demand function, I put 310. So minus 1/5 times 310 plus 124. So I get 62 when I do this calculation. And that basically is telling me $62 is what should be charged per unit to maximize revenue. And notice that that's your revenue is maximized when your price is lower. When we actually only had 8 million barrels of gallon, 8 million barrels of oil in stock, we had to charge $122.40. 8 doesn't even come close to maximizing revenue, having 8 million barrels. But having 310 million barrels does give us maximum revenue and allows us to charge a lower price.